So in this question, we are given three sets A, B, C, and the definitions are given. Let Z be a complex number and the number of elements in the set A intersection B intersection C. So first of all, let us take let Z equals to x plus iota y. Now our first set A. It is telling that imaginary Z is greater than equals to 1. So it represents the region y greater than equals to 1. Now set B. Set B says modulus of Z minus 2 minus I equals to 3. So this set represents points that lie on a circle. And what are the properties of this circle? Circle with center is 2, 1 and radius is 3 units. So what will be the circle? The circle will be x minus 2 whole square plus y minus 1 whole square equals to 3 square. Again, opening the brackets and simplifying, we will get x square plus y square minus 4x minus 2y equals to 4. Now set C. This set says real 1 minus I into Z equals to root 2. So this set represents the line x plus y equals to root 2. So points lying on this line. Now if we draw the graph and put the points, we will get a graph like this. A circle. The circle center will be 2, 1. So let us do 2, 1 over here. And the circle will be somewhat like this. Let this point be r0, root 2. And this point be root 2, 0. So the line will be, and another line is y greater than equals to 1. So this is the line. This will be the line, it will pass through 2, 1. So this is the line y equals to 1. Now we need to find out number of elements in the set A intersection B intersection C. So observing the graph, we can say that clearly there is only one point, one intersection point, which is this point. I'm doing it a different color. This point, the blue point. This point is the intersection of x plus y equals to root 2 and the circle, which is above y equals to 1. So we can say that there is only one element in A intersection B intersection C. So the final answer to this question is option B, 1.